The next part is you got this number 8 as your homework problem. Let me explain a little bit about number 8, and I'm not going to give away the answer, but at the same time I want you to take a moment to take a look to see what we're looking at. Number 8 is it basically asks you is look at these declaration of these statements. It says int num1 comma num2 num new num and a semicolon. So what the statement is saying is that each one of these things are declared as an int with separated by comma. I can do this as int num1 semicolon, next line down int num2 semicolon, but since they're all three the same data type, you can declare it one time with the word int. Same goes as double. You have x and y and ending with a semicolon in this thing. The question they're asking you is which one of the following assignments are valid? If an assignment is not valid, state the reason. Alright. So I'd like for you to look at this for a moment. Alright. Based on what we looked at as identifiers, remember these are variables. Variables consist of what? Identifiers. Identifiers consist of what? They're constants, functions, and variables. So if you look at this statement right here, starts with an identifier. Look at that identifier, that variable. Num is equal to 35. Let me just pull up a notepad, because in a statement like this, what you could do is think about how this works. Num is a good identifier. It starts out with the alpha and a number. That's perfectly legitimate. In programming, recall that I said in lecture, anything has an equal sign means the right side equals the left side. Anything I put as an equal, one equal, means that it's the right side equals to the left hand side. And it's with a semicolon. That's the ending of the statement with this thing. So this is a perfectly healthy, good statement if you think about it, right? So go through here with this, with keeping that what I just said in mind. Look at this statement. An operation tells it to subtract a number to assign this number with it. Is that a good number? Well, yeah, it's a good number. Okay? Look at this number. We have num1 is equal to 5, ending in semicolon. You plug num5 in, you put the memory 5 in this, add it to 2, that assigns it to the new num. Look at this operator. Whatever you see here is the right side equals the left side. So A, B, and C are perfectly healthy statement. Alright? Take a look at D. It's saying that, remember now, the equal sign, new num now equals num2. That's what this says. What's the problem with this thing? Well, I believe that once it says num1 times num2 equal to new num. That's what it wants to say. This is unless you want to say new num equals num2 times num1. So there's a problem with D, is my point. Look at E. If you took new num, okay, you're going to subtract that from num1, and then you're going to multiply with 2, and then that's going to equal to x. I would imagine that if you plug a 5 in here, alright, and this 5 right here, I'm thinking new num is 5, or new 35, it could be 35, subtract that from 15.5, so that will give you what? Some approximately 20.3 times that with it. So this is okay. Take a look at that. What's wrong with that? That's a healthy statement as well. Okay. So again, I mean it's a good statement with it as well. What's wrong with this statement right here? Remember now, there's an equal sign. It's saying that this statement right here. Let me snag this statement right here. So again, this is saying that here's this equal sign. You're saying new num now equals to 2. It's wrong. You can't do that. Okay, that's the problem with it. It always have to equals, if you don't have this, take this out, then it's a perfectly healthy statement. The right side equals the left side. Remember that, okay? But there is a problem with F in there, okay? So it's not possible, in other words, okay? Look at G. Let's say, again, think what I just said. Is there anything wrong with this? Look at H. Alright, is H a valid statement in here? Again, there's a problem here. Look, okay? So you're saying that new num mod 2, or num1 mod 2.0 equals that, okay? H is invalid because you're using the mod operator, and this has to be an integer. That's what's wrong with it. That's the problem. The mod, you have to do a mod with an integer. You can't do a mod with a decimal. That's the problem with it. Look at it. If you read about static hash says x is the expression, convert it to the data type of an int. I want you to mod that with this integer right here. This is a good statement, and all this is assigned to new num. This is a healthy, good statement. Look at J. J, you have, what do you think? All this operator now equals this. Okay, so I'll let you piddle along with this as we go along with this at the same time. Okay, so please take the time and go through these right now. I'm going to for you to take a look at 9. Now, suppose that you have this. Okay, here's what I'm going to do. So let me scroll up a little bit so you can see what I'm talking about. What I like to do is use a trace table, and you don't know what a trace table is at this time, but when we get into chapter 2 and chapter 3 and 4, I'll get more in detail about trace table. But let me just tell you what's in the integer of this based on what's a trace table. So what I'm going to do is I'm going to use this right here and kind of draw a little chart across so you know what's happening inside the memory. And you have 4 variables, 5 to be exact, right? X, W, X, Z, W, and T. I'm going to draw a line like this. Okay, you with me? So it starts out with the first line. It says X equal to 5. I'm going to put a 5 in that memory right there. And then it goes, I want you to plug that 5 into X plus 2, so it's what? 5 plus 2 now equals to 7. Okay? And then you look at Z, it gets a little bit more with it. So what's in the memory of Z? Let me do it over here. Z is equal to, X is what? 5 mod Y is 7 minus 2 plus 4. Look at this expression. What do you do first? Parentheses, right? So 5 mod 7 minus 2 is 5 plus 4. 5 mod 5 is what? 1. 1 plus 4 becomes 5. So Z now equals to, wait, I messed up here. 0. See, you gotta be careful. This is a 0. Okay, there's no remainder. My apology. 5 mod 5 is 0. There's no remainder. So this is 4. So this Z is 4. This is Z. Take a look at W. W saying, I want you to do X times Y. X times Y is 5 times 7. Here's W equal. And divide that all by Z is what? 4 minus 5. Okay, so do this first as 35 divided into 4 minus 5. What's 35 divided into 4? That would be 8. something in remainder. I don't really care, so it's going to be subtracted by, be some decimal, right? Some decimal. But this is an integer, so it's going to just take that 8, subtract that from 5, that's going to be a 3. So your W is going to be a 3. Let's look at T. T gets a little bit more elaborated. Let me find some room here. T becomes C is 4 plus X is 5 plus Y is 7 plus 2. They want you to mod that with W is 3. Okay, so here we go. Do whatever's inside the parentheses first. 5 plus 7 is 12 plus 2 is, that's 14. So that, and all that needs to still be there. Right? What happens first? This happens first. So it's 14 mod 3. The remainder is 2. 4 plus 2, right? That will equal to 6. Okay? So T is 6. So this is what you have across the board with this thing. Okay? That's number 9. Cool?